Okay, to plot a sine or cosine function, you can either use a table of values, which I recommend do not use, or you can use the mapping function or rule, or you can use something which is almost the same as mapping rule. But in my opinion, it's very much easier than mapping rule. But to show you what the technique is very simple. The first thing you have to do is to find the four characteristics of the function, which are amplitude, period, phase shift, and vertical shift. So by looking at this equation, it is obvious that the amplitude is what? 2. So I know the amplitude is 2. The reason is that the coefficient of sine is 2. Okay? Now, for vertical shift, you look at the number which is added or subtracted, and you can see the number is +1, so the vertical shift is 1. The next one is the phase shift. The phase shift, you look at the number inside the bracket with x, and you can see it's -15. But to find the phase shift, you are going to flip the sign, so it's going to be 15 degrees to the right. So the phase shift is 15 degrees right. Vertical shift is 1 unit up. Now, the only thing I have to find now is the period, P. To find the period, this number helps me. This is B. Remember that period and B are related with the following formula. 2 pi over B is equal to period. Or you can say 2 pi over 3. So the period is 2 pi over 3. Now, either you can use pi or you can just change it to degrees if it's much simpler. But I'm going to change it to degrees. 2 pi over 3 is 360 divided by 3, which is 120. So we know that the period is 120 degrees. So this means that on my graph, I'm going to specify 120 to be something like this one, assuming we are supposed to plot only one cycle, okay, of the graph. If they said 2 cycles, then I have to divide this one to 220, so it's going to be 240 degrees. The next thing you do, you divide that period into 4 equal parts. So the first part is going to be 60. The next one is going to be 30. And this guy is going to be 90. Now, what you do is that you ignore these two, phase shift and vertical shift. Forget about them. Just plot the graph corresponding to amplitude 2 and period 2 pi 3. Okay? So this is going to be y equal to sine period is 2 pi 3. Okay? So it's going to be, I want to plot only this guy, 3x. That's all I'm going to plot at the moment, which is very simple to plot. Remember, the sine function has this property. It starts at 0, goes to maximum the first quadrant, then goes to 0 the second quadrant, then it goes to -1, and then goes back to 0. So 0, 1, maximum, let's put it maximum, 0, minimum, and then 0. So this means that my function starts here. It goes to maximum, which we said the amplitude is 2. So this is 2. This is -2. So it goes to this point. I'm using open circle because this is not the graph yet. This is the base function for this guy. So 60 is going to be 0. Then 90 is going to be minimum, and then 120. My base function looks something like this. Okay? Without any transformation yet. The other two are left that you have to do. Now, how do you apply these two transformations? Phase shift 15 degrees. Remember, I am going to move to the right. Okay? And 1 unit down. So this means apply all these transformations to every single point. So for this point, remember that this one is -30. I want to go 15 degrees to the right, okay? So I'm going to go to this point here. Let me just show you what I mean. I'm going to go to middle here, and then I'm going to go 1 unit up. So I'm going to end up here. I put a cross here. I hope everybody understands. The next point is this maximum here. This is the next point. I'm going to move 15 degrees, which is half of this distance to the right, and then 1 unit up, which is going to be 3. So I'm going to end up, if I continue here, somewhere around here is 3. So I'm going to go right 15 degrees and then go up 1 unit. So I'm going to end up here. The next one is this point, which is shown here. Now I go 15 degrees to the right and 1 unit up. So I'm going to end up to a point which is shown here. The next one is this point. I'm going to go right 15 degrees and then up 1 unit. So I'm going to end up 15 degrees and up 1 unit. I'm going to end up here. And the last point is this point, which means I go again 15 degrees to the right and 1 unit up. So I'm going to get to a point which is shown, let's say, somewhere around here. Now, these are the points that I have to connect. So my graph will look something like approximately like this. Now, you're not done yet. To show me in your test, the unit test, you have to tell me what are the coordinates of these points, which is very simple. For instance, we said that the first point I started was this point. I went 15 right and 1 up. So this means 0, 0 becomes 15 and 1. So this point becomes 15 and 1, 15 degrees. This point becomes 45 and 3. This point becomes 75 and 1. This point becomes 90 plus 15 is 105 and negative 1. And the last point, which is this guy, is going to be 100. What was the last point? 135. So 135 and 1. And that's it. That's the graphing. For the following graph, you're supposed to find the equation in terms of sine or cosine. It doesn't matter which one. But by looking at the graph, you can see that the graph starts at other than 0 when x is 0, so probably a cos is the better choice here. But let's see how we are going to find cos or sine in general. To do that one, I need to find A, which is the amplitude. By definition, amplitude is maximum minus minimum divided by 2. The maximum is here, the minimum is here. This means the maximum is 0.5 minus the minimum, which is negative 0.5, divided by 2, which is 1 over 2, which is 0.5. So my amplitude is 0.5. Now, the next thing I'm going to find is D. I told you D is, instead of subtracting the max and mean, we are going to add the max and mean now. So I'm going to say 0.5 plus negative 0.5 divided by 2 is going to give me 0. This means that x is the axis which is going to make the graph in half, upper half and lower half. This is what we call the axis of horizontal, which is this line now. So I have A and D. Now I have to find B. To find B, I know that period and B are related with this formula. Now, looking at this graph, I have to find what exactly is the period here. So what I'm going to do is that I'm going to pick 2 points here, which hopefully are going to help me, to find the period. So I'm going to pick this point, which is pi over 2, and this point. Okay? And I'm going to find what exactly is the period. I know this is pi over 2, this point. I know that this interval from here to here is divided in 3, and this one is equal to pi over 2. So every unit here is pi over 6. Okay? So this one is really pi plus pi over 6. Now what I'm going to do is that I'm going to find period to be pi plus pi over 6 minus pi over 2. This is pi plus pi over 6, and this is pi over 2. If I subtract them, I'm going to find the distance, which is the period. Let's do the calculation here. I will make everything to the denominator 6. So this one multiplied by 6 divided by 6, multiply by 3 divided by 3. So I'm going to get 6 pi over 6 plus pi over 6 minus 3 pi over 6. Now 6 pi plus pi is 7 pi minus 3 pi is 4 pi over 6, which is going to be 2 pi over 3. Okay, so that's my period. Now knowing the period, I can find that B is equal to 2 pi over 1 divided by period. Period is 2 pi over 3. Okay, this one, again, I can write as 2 pi over 1 times 3 over 2 pi. 2 pi goes with 2 pi, so the answer is 3. So automatically, I know that y is equal to 0.5. If I want to express it in terms of cosine function, I'm going to have 3 open bracket x, okay? But look at the phase shift. You can see that the function starts at its maximum when x is 0, which is exactly like cosine function. So there is no lagging here, okay? So the phase shift here is 0. So I can write x minus 0, which is the same as 0.5 cos 3x. So this is my function in terms of cos. Now, you may say, okay, how can I express it in terms of sine? We just found out on the board that we said that whenever, okay, if I express this one exactly like a sine function, I'm going to get 0.5 sine 3x, 3 times x, but your sine starts at 0. Now, one thing you have to remember, in regular sine function, which goes from 0 to 360, you divide it by 4, you get 0, 90, 180, 270, and 360. In this case, your period is not 360. Your period is 2 pi over 3. So if you divide this guy by 4, what is 2 pi over 3 divided by 4? Divided by 4. Which is going to be 2 pi over 3 times 1 over 4, which is 2 pi over 12, which is equal to what? Pi over 6. Right? Now, again, we said it before that if this is my sine function, remember, I have to move it back 1/4 of a period, because here is the maximum of the sine, which is 1/4 of the period. This means that I have to move it back how much? Pi over 6. Since I go left, what is the phase shift here for sine? Positive. So this is equal to 0.5 sine 3 times x, positive pi over 6.